Hey everybody! In this bonus talk video, I will be discussing Excel backgrounds in Mode 0. So, basic review on the Mode 0 background sizes. There are 2 bits that we set in the background control registers to determine the size of the backgrounds we show on screen, which means we have 4 different options for that. We have a small background, which is just one screen block that's thrown on screen. We have wide backgrounds, which are 2 screen blocks placed next to each other. We have a tall background, which is 2 backgrounds stacked on top of each other, and we have large backgrounds, which are 4 different screen blocks that are placed together in a square pattern. And basically for all of these, it's like if this is screen blocks 0, 1, 2, and 3 all placed contiguously in memory, right? Like if I have 0 and 1 here, this wide background will put screen block 0 here, put screen block 1 here. This tall background puts 0 here, 1 here, and of course large put 0 here, 1, 2, 1 here, 2 here, and 3 here, even though they're all laid out this way in memory, basically. So this is nice if we only want to have backgrounds that are like 512 by 512 pixels max, because that's the size of a large background, because one single screen block is 256 by 256. Large is going to double that in both directions. We'd get 512 by 512. And maybe we want to have maybe a little bit longer background. Like if you ever played like the old Mario Brothers games, they have pretty long backgrounds, definitely longer than 512 pixels. And they're unique. They're not like looping because the backgrounds will loop if we just like scroll past them. But in something like Mario, they are going to be very different depending on where you are in the map. And that's some behavior that you may want to emulate in your final project. So in order to represent something like this, how do we go about it? This is 7 screen blocks long, so it's 256 tall, and whatever 256 times 7 is, I'm not doing the math on the spot, but it's that number, and we would need some kind of system in order to use these types of backgrounds in order to selectively show parts of this at different times, basically. So one thing to note is the size of our viewport, right? So it's going to take up about this much space in our screen block. This is just a rough estimate, right? And something to notice about it is that it's not even close to as tall as one of these screen blocks. And it's not as wide either. So you're never going to have a situation where the viewport is taking up more than 2 screen blocks in either the X or Y directions, right? This is not possible because the screen is not this wide. We will only ever see things like this. So in reality, we really only need to be showing 2 screen blocks at once. Like this one right here, maybe we'd show 1 and 2 because this viewport is showing parts of 1 and 2, for example. So that's all right with us. We only are able to show 2, and that's fine because we only ever need to show 2. There will be times, if you do want to have this extend in both directions, where you want to use like a large background and show 4 at a time, like at this intersection, but that will be for a little bit later. So in order to actually change the screen box we're looking at, that's something we can handle in the background control registers, right? Because we actually set the screen block that we want to show as like part of the bits in there, the screen block base. And as we move through this background, we can say, okay, maybe I'm in screen block 1. I want to make that my screen block base. And that's a way we can actually like select which 2 of these screen blocks are being shown at a time. And the way we actually get that value is say that this top left corner of the map is going to be 0, 0, right? If we have the distance between the left side of this map and the top left corner of our viewpoint, or our viewport, then we can measure that distance and we can use it to determine how far into the screen blocks we need to go in order to get the one that we need. Like for example, maybe this viewport is at x equals 300, y equals 30 or something. The Y is more important for the vertical XO backgrounds. This is the horizontal one, so we'll focus more on the on like the HOF sort of stuff, right? So we've been using HOF kind of to determine how far this should be from the corner of the screen, the top left corner. But if we're using it to determine the top left corner of the map, we can actually use it to figure out which screen block we're in, because we can do some integer division here. This is at 300. We can assume it's in screen block 1, but when we actually do the math, 300 over 256 in integer division is 1. That's the screen block we're in. Maybe if it's at like 500 something, I don't know, something bigger than 512. If this was at like 630, and we did that math again, we would get 2, because we're in screen block 2 right here. And we're doing like integer division, right? So once we have that number, we can actually just go ahead and throw it into the background register during like a draw function. So I do believe this, you do need to wait for VBlank to do this, because like you are like changing around a lot of data, and the hardware is not necessarily equipped to do that all on its own in like vdraw. So you would need to do this in a draw function after waiting for VBlank. So something else to take into account. This spot right here, this spot 0, 0, that's never going to change throughout the entire run of the game if you set this up correctly. But for the screen blocks, and specifically the offset of the viewport to the top left corner of your screen blocks that are being shown on screen, this will be changing almost all the time. This position right here. This is going to be changing a lot depending on which screen block you're actually in. The only time your distance from 0, 0 in your map and your distance from the top left corner of your current screen blocks, the only time it's going to be the same is when you're in screen block 0. So we need to account for this when we're actually setting our register, right? So the way we can do that is we can use modulus, specifically modulus by the width of our screen block. So the way this kind of works is, let's pretend we're at 300 again. If we do like long division between 300 and 256, right? That's going to give us a value of 1. That was our screen block from before, right? But when we subtract this and get the remainder, I believe that's going to be 44. That looks right. This will become the result of our modulus operation, because we're getting the remainder from this division. So that 44 right there is going to accurately represent the distance between the actual left side of our screen block base area and our viewport. If we were to go to screen block 3 at like 44 from the left side of this area, then did that math, the modulus would just like multiply this number by however many screen blocks we need to skip, basically. That number would go here, that'd be the screen block we're in. This would end up being multiplied by 3. So that would be like a 3 here, multiplied by 3, do the division here, or the subtraction here. And we would still get 44. So this is a system we can pretty much globally use in order to get the distance between the edge of the screen block that we're in and our actual viewport. So we can use that when we're actually setting our register. And there is an edge case with this system, right? Because we're always displaying 2 screen blocks in every situation. And we're basically just looking at this point here and saying which screen block are we in. However, when you reach the very edge of your map on the right side, there is going to be this edge case where you're going to be looking at this last screen block, screen block 6, but you're also going to be trying to look at screen block 7. So we don't expect anything to be here because we haven't set any of those screen blocks in there. So basically what we want to do in order to avoid any of this from being shown, because this is the edge of our map, there's nothing beyond it. What we want to do is make sure that this point right here, or I guess more accurately, the right side of our viewport, we have to make sure that never crosses this line. We want to clamp it inside of this range, basically. So the smallest possible value for this should be 0 over on the left. So we shouldn't be able to scroll farther left. And going farther right, the farthest point this can go to the right should be the width of our entire map subtracted from the width of our screen, or actually the width of our screen subtracted from the width of our entire map. And that'll put the point somewhere around here, basically. And if we try and keep scrolling farther, we end up just running into a wall, basically. We can't move past it, and then screen block 7 never gets shown. So that's the basic idea here. Um, if we want to do a vertical background, we can just do all of the same logic we did here, except we just use y values instead of x values for a lot of this stuff because the actual XL portion of this background is going to be in the y direction for a vertical background. So, oh, got a Teams message. That's fun. Guess now's a good time to segue into the demo. So let's look around for a bit in here. Something is funny apparently. I'm gonna go ahead and mute Teams. Teams quit. Okay. Might need to cut that out for FERPA reasons. We'll see. Okay. So if we look around in here, let's see what we've got. First of all, we've got this macro here, this clamp macro. We're going to use this in order to keep our background from going outside of our bounds of our map. It's basically like if we have a specific value that we throw in here, it's going to be bounded between min and max when it returns back. Next, we've got some other macros in here. This is just the width and height of each of our different types of backgrounds in screen blocks. We're going to be changing this when we add more screen blocks to our background. All three of these different ones. We've got our h off and v off, which we're going to be using to check the distance from our viewport to our viewport to 0, 0 on our map. And map width, map height are just going to be the width and height for map in pixels. We've got our usual initialize, update, and draw. And we're going to have a nice little state machine that is going to allow us to switch up on the fly which kind of background we're using. We maybe want to be looking at a wide background, a tall background, or a large background. So we go into the actual demo. This is going to be our wide background. We're just starting off with 2 screen blocks for now. We have screen block 0, screen block 1. Those are the bounds. Press the right shoulder, and we can show a tall background, which is going to be just 0 and 1. Press the right shoulder again, and we can show a large background. We have 0, 1, 2, and 3. And those are the bounds that we have. These are already clamped, so that's going to be a little helpful for us. So these are the backgrounds we're going to actually try and show at the end of this. Got this wide background. It is about 8 screen blocks, or it's 9 screen blocks wide right now. And all these are like 9 screen blocks in terms of size, right? We've got our tall one, which is going to go in the same direction, and we have a large one, which is going to be a grid of 3 by 3 screen blocks in both the X and the Y. So one thing you might notice is that if you look at our files, there's only one here for backgrounds, this BGXL, which is going to be basically this, right? It's going to take all these screen blocks and put them in the different places in memory. And this is kind of interesting because the orientation of our backgrounds doesn't necessarily matter as long as the screen blocks are placed in memory in the right place. So if we're looking at a wide background and our backgrounds are in the corresponding screen blocks, it's going to show like 0 and 1 if we're at screen block 0. It's going to show 3 and 4 if we're at screen block 3, so on and so forth. And tall is going to work exactly the same way. It's just going to place them on top of each other instead of beside each other. This is all the same data. We're just displaying it in different ways. So here's our main function. Got our draw function up top. This is what we're going to be messing with the most. Right now, we literally just have h off and b off, and they are being, like the registers are being set directly to those values, and those values are being updated in here with this clamp function, which is going to keep us from going outside of our bounds. Here's a little state machine. We can just go back and forth between all these with our left and right shoulder buttons. We can move around with the arrow keys, or I guess the D-pad. Got a standard main loop here. In initialize, we are setting our mode to 0. We're only using one background here. We are DMAing all the stuff we need into the correct places. And we're setting h off and v off to 0 at the start. And we also have these state transitions, which are basically going to reset our h off and v off back to 0. They're going to set new map width and map height values for us based on both the size of a screen block, 256 pixels in both directions, and the width and height values we have set for each of our different types of backgrounds. We need those for clamping. And right here, we have our background control register, which we're going to be setting every time we change our type of background, because we need to reset these registers to give the correct settings for each one. And everything's just going to be in from 0, screen block 0 to 9, just as they're labeled. All tiles are in character block 3. So, the first thing we want to do probably is actually change up the size of our background, because we don't want it to clamp off at microphone just died for a second, my bad. So we don't want our backgrounds to just like be clamped to these smaller sizes. We want to actually use all the space that we can. So because we have 9 different screen blocks that we're working with, let's make the width and height of these tall and wide backgrounds respectively. Let's make those 9, and let's make the large background 3 and 3, like it was in the image. And let's see what kind of behavior this gives us when we build this back. Okay, so I'm scrolling right, and our background's looping. And just going back to 0 and 1. And eventually we hit a limit, and that's just going to be here with the 0. It's looped around like 3 or 4 times. That's what the backgrounds do when we scroll past their bounds like that. This one's going to be similar. You just go down, do the same thing. And this one here is interesting. We get like a 0 at the end here. Go down to 2 and 3. We get a 2 here. So that's what's looping around from this bottom part. And we're going to get a 0 down here, I believe, and a 1 over here. Then here we get another 0. It's just basically a repetition of this top one. So the size of our map in terms of scrolling is correct, but we're not getting these screen blocks to appear in the right places like we want to. So we actually need to go in and change up these screen blocks we are looking at in order for that to work. So right here we have this variable, current SPB. We're going to use that in order to get our stuff to go to the right place. So let's set its value. Current SPB is going to be equal to our HOFF divided by 256. And now we can just set the background control register in here. I can type properly. EG0CNT. That's our control register. We're in wide right now, so let's do, oh, I must have gotten rid of these 2 lines. Let's just throw those back in there. They're the same from all 3 states. Okay, there we go. So we want to keep this as a wide background. So let's do BG size wide. For our screen block, We literally just want to go in here and set this value to current SPV. Just like that. That's all we need to do. And of course, we're getting our tiles from the same place as we were before, character block 3. And the last thing we need to do is we just need to make sure that the register is using the correct offset values in order to actually show this on our screen. So we just do a mod 256 for each of these. While we're at it, we might as well just take this and put it onto tall as well. So this would be V off instead of H off. All of this stuff here should be the same, except rather than doing a wide background, we do a tall background. And once again, we want to mod by 256 to get the correct offset values. So let's see what happens here. Oh, we're forgetting to break. This could be interesting. Yep, that was in fact interesting. Let's go ahead and rerun that with the break there. Okay. Now there's 2, 3, 4, 5, 6, 7, and 8. And we are clamped off here at the end, exactly where our background ended. That is what we like to see. Let's look at the tall one. Press the right shoulder, and now we can go down. 1, 2, 3, 4, 5, 6, 7, and 8. And our large one is still configured the same way it was before. We are going to mess with this one now, because this one is going to work a little bit differently from the wide and the tall. And there's a good reason for that. And that good reason is that if we look at this, this is going to be taking 0, 1, 2, and 3, those screen blocks, and it wants to put them in a square. However, if we were to go and try and make a background that looks like this, you can see this is not 0, 1, 2, and 3. It's 0, 1, 3, and 4. In fact, these 4 screen blocks, all 4 of them together, are not placed contiguously in memory. So we can't do something as simple as this, right? Where we just kind of throw the wide background into like a screen block or something. We can't necessarily do something like that because the screen it's essentially in it's split into 2 contiguous sections. We have like this 0 and this 1, and we have this 3 and this 4. These 2 rows are both contiguous, but the whole entire thing is not. So we need to sort of separate this out and work on it that way. Um, and it makes it kind of difficult because we can't necessarily like go through and do that. So what we kind of have to do is we have to reserve some extra space in our VRAM, basically, where that space is contiguous, and we just need to DMA the stuff that we need into that contiguous spot so it can be shown, basically. So you would DMA screen blocks 0 and 1, and then you would DMA 3 and 4 into a space more like this, because 9, 10, 11, and 12, those screen blocks are going to be contiguous, so we just want to go ahead and do that, basically. So how do we actually do the positioning stuff? We want to figure out what this top left corner is of these four blocks. And the reason for that is because, first of all, if we have top left corner, we know exactly where the top right corner is. That's just the one above the top left corner. 4 goes to 5. But we also know, if we know the top left corner, we know what the bottom left corner is as well, because we can use offset to figure it out. This screen right here is 3 blocks wide, right? If I start at 4 and I move over by 3 spaces, 1, 2, 3, that's the width of our background, we get to 7. So we can use that to figure out where this bottom row is going to be. And basically, that's what's going to get us these two source addresses, I guess, for our stream blocks that we're going to use for our DMA transfer. So if we want to get the H off and V off of our viewport, which is another thing that's going to be important, that's another thing we want to use offset for, because this space right here, we have it's got like an X distance and a Y distance, right? If you were to do the similar logic to what we did up in here, I believe, do something like this, what you would end up getting is, if I was to do this for the X, for example, there's one full screen block here that's been used, and one partial one. So this was give us a value of 1 in the X, and coming from the bottom, we also have the similar situation. There's one full screen block being like skipped over here. So that's going to give us a value of 1 in the Y. So if we do an offset function with X value of 1, Y value of 1, and a width of 3, we do end up getting to our screen block 4. So this is going to be our strategy for actually figuring out what these screen blocks are going to end up being. So let's go ahead and write some of this stuff in. So if we come here, we want to get our current screen block base. And what we'd want to do is we want to use the offset function. Just like that. Our X value would be H off for 256. Our Y value would be V off over 256. And our width is just going to be the width of our background in screen blocks like we've been using. So that's just going to be large XL SB width. Just for reference, that is going to be, in this case, it's going to be 3 right there. So that's going to give us our current screen block. And we can use that when we're actually figuring out what our source address for our transfer is going to be. Because we're actually not going to be displaying at screen block 4 like this. Because again, these things are not continuous. We cannot show a square at this location using these indices. So instead, what we're going to do is we want to take these and basically just throw them into a different screen block. So to get that going, let's actually go to here, go to large, and take a look at this. So our background control register right now, it's pointing at screen block 0, which is where all our data is. But we want to go somewhere that's empty and fill up 4 of those screen blocks with the stuff that we need for. So let's instead go to screen block 9. That's going to be right outside of the range of our screen blocks the way they are, because we're going from 0 to 8 with this. So those 8 screen blocks are taken up completely by a map, so we don't want to overwrite those. So we'll just go do 9 through 12. Just like that. And in here, what we're going to do, instead of setting the background register, we are going to do a couple of DMA calls. So let's do DMA now. Our channel is going to be 3. That's general purpose. Our base screen block for the source, we're going to transport from one of our screen blocks. And that screen block is just going to be our current SBB, just like this. And our destination, that's going to be screen block 9. And as you can see, if you're looking at this, screen block 0, which would be the current screen block in this case, would be going to screen block 9. There's also the issue of how many copies do we want to do, right? Because we want to copy 2 screen blocks worth of data in this DMA call. So we know if we go to mode0.h, let's take a look at this struct. So this struct is going to be basically just storing an array of U16s, so that's 2 bytes each, and they're going to be 1024 of these U16s in this array. So if we want to know the total size of this thing, we can just multiply 1024 by 2. That is going to be 2048. That's going to be the size of a screen block in bytes. But as we know, DMA cannot transfer stuff byte by byte. So we basically want to do this in 16 or 32-bit chunks. 16-bit chunks is pretty convenient here, though, because that's how many shorts we have in our struct. It's just 1024. They're all 16-bit chunks, so we might as well just take the size of our array and do that. However, we are doing 2 of them, so we can just multiply that by 2, and that will get us two total screen blocks for our number of transfers right there. And if you want to be clever, you can do something like this as well. Size of SB, because we know that a screen block is going to be 2048 bytes total, and we're doing like 1024 transfers per screen block. And if we do 2048 transfers, we get 2. So that works out pretty well for us as well. But we have to make sure we're transferring 2 of them. If we want to transfer 1, you would divide this by 2. But in this case, we're just doing 1. Or we're doing 2 of them. So that would be just, you could choose size of SB here. Then we want to get the second row. So that's going to be another DMA call here. Again, our channel is 3. We're going to be using a different screen block now. We're going to be using the one on the bottom row. So here, we just want to do our current SVB plus our width, large XL SB width. So that's going to take us down by 1 row. And we also want to make our destination go down a row. So we can we can take that to screen block. Let's take a look at our image actually. In our image, the bottom row is at the left side of the bottom row is at screen block 11. So we can do screen block 11 as our destination. And once again, we can do size of SB as our number of transfers. We're forgetting a brace there. We'll see if that fixes it. Okay. And last thing, of course, we just want to mod the H off and V off by 256 here. So if we go to the large background after this loads, we should be able to see the rest of our screen blocks. All right, so press the left shoulder button to get there. There's 0, 1, and 2. We're bounded at the edge. That's looking good so far. We've got 3 here. We've got 4. We got 5. See, we're at this intersection here. Like, we can see 4 of our screen blocks. We can see 1 and 2, and also 4 and 5. And those aren't placed contiguously. We've got this correct. They're all in the right spots. And here's 6, 7, and 8. That's the right edge. There's the bottom edge. We cannot go any lower. So this is looking pretty great so far. However, there is a limited amount of space that we have in VRAM for this kind of stuff. We only have 32 total screen blocks that we can work with. And what if you want to make a background that is absolutely massive? Like, this thing is going to be like 256 times 3 down this way, and whatever 256 times 11 is going this way. That's a really big background. And I'm going to make the claim here that it's totally, completely possible to do this. This is going to be a triple X background. So the basic idea behind this is we are going to import something like this from one of our imports, like you sent here tiled, right? And this is going to exist somewhere in our memory, in like constant memory someplace. If you look in the .c files, they have like the const modifier on them, which puts them in a special place. So we're going to have access to this. You're just not going to be able to change it, right? So what we can do, rather than throwing the stuff into screen blocks like we did with the large backgrounds, we can just leave them where we are and mess with the pointer a little bit to get the data we actually want. So when we import these maps, right, they're usually going to be U16s just to make it simpler to work with them generally. Um, but what we can do is we can actually recast these pointers. Like if we go into here and look at this, it's a constant time short array, right? We at the end of the day, these arrays are it's just an address at the end of the day. A constant pointer almost. And we have the freedom in C to cast this to whatever we like. So why not just cast it to a screen block pointer and index it like you would an array of screen blocks? If I were to do this with like index like 18, we could get to screen block 18 just like this. And we can use this sort of format to work this like to make it work the same way as like our large backgrounds, right? Where we just go to screen block 18, get that, get 19, then we go down a row and we get 30 and 31. It's as simple as that. You would also need to do the same if you had like a super long wide like XL wide background, super long tall XL background. You could do something similar with DMA because again you wouldn't be able to store those in in VRAM. Um, yeah, so for those like we have this method, this DMA list method for them, which is nice when we can fit it, but when we can't, you would have to switch over to something more like this for a longer background, basically. This is a more general way of getting these screen blocks to where they need to go. So before we finish this off, I just want to show you this method does work, and I'm going to do it by changing up this stuff here, this source address for these two rows to our actual BGXL map. So let's go ahead and take away our screen blocks, place those with some parentheses here. Let's add in BGXL map, just like that. That's going to be our pointer to our array. And let's just cast that to a screen block pointer. Let's do that for both of these. So really, if we do it this way, we wouldn't have to import them into the VR at all until we actually needed them. So if we go back to the large background, we should see that it is working exactly the same way as it was before. Got your 0, your 1, your 2. Got your 3, your 4, and your 5. And you've got your 6, your 7, and your 8. And there's the bottom right corner. So there you go, guys. That is XL backgrounds in a nutshell. Um, if you guys are planning on putting some big, really, really big maps into your games, I suggest going about it in a way like this, or whatever works best for your game. If you're shooting tall or wide, some of the DMA list strats will work really well for you. But if you're doing something more like this, then the DMA stuff is going to come in handy. So that's about all I have to say on the topic. Thank you for watching, and wish you all luck with your final projects.